Hello friends, how are you? Today we shall study diode, in which PN junction diode, forward bias, reverse bias, application of diode as a rectifier, and special purpose diode, Zener diode, and optoelectronic device. So talking about diode, what is diode? Diode is a two-terminal electronic component that conducts electricity primarily in one direction, and it has high resistance on one end and low resistance on the other end. So what is an ideal diode? Ideal diode is a diode that acts like a perfect conductor when voltage is applied forward bias, and it acts like a perfect insulator when voltage is applied reverse biased. Junction diode is a very useful semiconductor diode in which PN junction is attached with metallic contact at the end to apply external voltage. And here is the symbol of diode. So this is the symbol of PN junction diode without bias. The device has two terminals, anode and cathode. Therefore, it is called diode, and it is electrically asymmetric. Why? Because current can flow freely from anode to cathode but not in the other direction. Here are the uses of diode: to turn AC into DC, isolating signals from a supply, mixing signals. That are the uses. And diode has two sides, each sides can be doped differently, and it is electrically asymmetric. In reverse bias, barrier height increased, and in forward bias, barrier height decreased. Why? Because applied voltage in reverse bias drops across depletion region, and direction of applied voltage and barrier potential is same, and therefore depletion region widens and barrier height increases. So effective barrier potential and effective barrier height is V0 plus V. So this suppresses the flow of electrons from N to P. And under forward bias, depletion barrier decreased and barrier height reduced. And effective barrier height will be V0 minus V in forward bias. Why? Because direction of applied voltage V is opposite to built-in voltage V0. If applied voltage is small, then very few electrons can cross the junction, so current will be small. Now one more thing is happened. Due to applied voltage, electrons from N side cross depletion region and reach P side, and holes from P side cross depletion region and reach N side, where they are minority carrier. This process is called minority carrier injection. Remember this by looking at the figure. Up to particular value of voltage, reverse bias is voltage independent, and that value of voltage is called breakdown voltage. After that characteristic voltage, diode current increases significantly even for a small increase in voltage, and this is called threshold voltage. And total diode forward current is equal to hole diffusion current plus convention current due to electron diffusion. So now moving towards application of diode as a rectifier. And diode as a rectifier is used wherever huge current should flow throughout the diode, and it has voltage drop of 0.7 volt, and they are made with Si. AC voltage is connected across the diode in series with load. What will happen? We get pulsating voltage across the load only when diode is forward biased, so it is called half wave rectifier. And when we have two diode circuit, it gives output rectified voltage during both the cycles, positive as well as negative. Therefore, it's called full wave rectifier. There are two types of circuit for full wave rectifier: two diodes and center tape transformer, or you can use four diodes in bridge configuration. And for input AC source, you can also use transformer without center tape. Vacuum tube and mercury arc are examples of rectifier. In two diode circuit, during positive half cycle, due to center tape, D1 gets forward bias and D2 gets reverse biased. And during negative half cycle, D1 get reverse bias and D2 gets forward bias. So we can get current during both the cycles. Rectified voltage is in the shape of pulses, which is half sinusoidal. Output voltage doesn't have a steady value, and to get steady value we have to connect capacitor in parallel to load RL. And if you want to use inductor, it should be connected in series with RL. So the external circuit having capacitor or inductor is called filter because it gives pure DC voltage. So when there is no external load, capacitor remains charged. But when there is an external load, what will happen? It gets discharged through load. And again in next half cycle, it gets charged to peak voltage. So it acts as a filter. So now moving towards special purpose diode. Zener diode is special purpose diode for voltage regulation. It is heavily doped on both the sides, so depletion region is very thin and electric field is very high. Increase in input voltage, increase in current. So voltage drop across RS is increased without any change in voltage across Zener diode. Similarly, for decrease in input voltage, decrease in current, and voltage drop across RS decrease without any change in voltage across Zener diode. Even for a small reverse bias voltage VZ, means breakdown voltage, we can see large change in current. Even after VZ, also large current can be produced by insignificant change in reverse bias voltage. So this property can be used to get constant voltage supplied even when there is a large variation in current. So now moving towards optoelectronic device. So we are going to study three types of device: photodiode, LED and photovoltaic device. Photodiode is used to detect optical signals and LED is used to convert electrical energy into light. Photovoltaic device, which is solar cell, is used to convert optical radiation into electricity. And photodiode is a special purpose PN junction diode which is fabricated with transparent window to allow light to fall on the diode. It is operated under reverse bias, and so when the photodiode is illuminated with the light, means photon with energy h nu, which is greater than energy gap Eg of the semiconductor, then the electron hole pairs are generated due to absorption of photon. Now in LED, it is heavily doped PN junction under forward bias, which emits spontaneous radiation which encapsulated with transparent cover so light can come out. Low operation voltage, less power, fast action, no warm-up time, bandwidth, emits light 100 angstrom to 500 angstrom, which is nearly monochromatic, long life and fast on-off switching capability. These are the advantage of LED, which can be used in today's TD. Solar cell, it's a PN junction which generates EMF when solar radiation falls on it. Same principle of photodiode, except no external bias is applied and junction area is kept larger for more power generation. So 3 points should be remembered: generation, separation and collection. Generation of EH pairs due to light h nu, which is greater than Eg, and separation of electrons and holes due to electric field of depletion region. Electron is moving towards N and holes are moving towards H. Electrons are collected by front contact and holes are collected by back contact. Production of low-cost solar cells or photovoltaic cell is still under research. So folks, that's all for this video. See you in next video. Thank you for watching, and if you like, please share and subscribe.